Hello all, I am Divya Kumawat, and in this lecture we will be studying about representation of 3-address code or the implementation of 3-address code. Basically 3-address code can be represented with the help of quadruples, triples and indirect triples in memory. Let us see all this one by one. Quadruples. As the name is suggesting that quadruples has 4 fields. One is OP, that is representing an operator. ARG, that is argument 1, then ARG2, that is argument 2, and the result. So if there is an instruction x equals to y plus z, in that case plus will be the operator, y will be the argument 1, z will be the argument 2, and x will be in the result. Just take the example. Suppose this one is a 3-address code and we want to store it in the form of quadruples. So there will be 4 field: operator, argument 1, argument 2 and result. T1 is storing the value minus c. So minus is the operator, so minus will come here and c will be the argument 1. It does not contain the third operator, so second operator. So second argument will be blank and the result has been stored in T1. Similarly, in the second instruction, B asterisk T1 operation is performed and the result has been stored in the T2. So asterisk will be our operator, B will be the argument 1, T1 will be our argument 2 and T2 will be the result. In the same way, at the second memory address also, we have calculated minus C and result has been stored in T3, and T4 is holding B into T3. Then at T5 result is holding the addition of T2 and T4. So T2 and T4 will be argument 1 and argument 2 respectively, and the operation that is being performed is plus. Then the result is being stored, T5 result is stored in a variable. So here argument 1 will be T5 and operation that is being performed is assignment operation, so equals to sign is there and the result is there in the a variable. Now we come over the triples. A triples has only 3 fields: operator, argument 1 and argument 2. It does not use temporaries. In the last example, we have used a number of temporary variables such as T1, T2, T3, T4, T5, but this triples will not be using it. Instead of that, it will be using the reference to instructions. How it will be, one instruction can be converted into the triples is shown here. Again, here we have just shown the syntax tree, but directly from the 3-address code also we can do the conversion. Like at 0th moment, B into minus C is being calculated. First of all, minus C is calculated and after that B into minus C is calculated. So at the 0th memory address, minus C is there. Then after that, B into minus C is calculated. So minus C has been calculated at 0th memory address. So after that we have to perform the multiplication. So we will be multiplying B with the value that has been calculated at 0th address. Then on the second memory address, again minus C will be calculated. So at the place of operation, minus will be there and C will be there at the argument 1. Then the next step, we will be calculating B into minus C. So minus C has already been calculated at second memory address. So this value will be the argument 2 for the next instruction. So multiplication operation will be performed. One operator will be B and the second operator, that is minus C, will be taken from the second memory location. After that, we have to perform the addition task. We have to add this left subtree with the right subtree. So this left subtree operation has been calculated at memory address 1 and memory address 3. So we will be passing that reference as argument 1 and as argument 2, and there will be the operation plus present here. Till this point, till the 4th location, we have calculated this much of the right subtree. Now the task is to assign this value to A. So that will be performed with the help of equals to operation. And what we are going to do, we are going to add this right subtree value to the argument 1, that is our a. So a will be assigned value that has been calculated at 4th memory address. This is all about the triples. Now we come over the indirect triples. It is an advancement or enhancement of triples. It uses an additional instructional array to list the pointers to the triples in the desired order. So instead of position, pointers are used to store the result. It allows the optimizer to easily reposition the sub expression for producing the optimized code. This is one of the example of indirect triples. It is similar to the triples only, but here one more list of pointers are present. Like this one is my actual means addresses which is considered, but in reality in memory it 0th instruction will be present at 14th memory address. First address instruction is in actual reality it is present at 15th memory address. So that's why it is known as indirect triples. So as we can see, in case of quadruples the result field is different. So if we move the variables or addresses or swap the addresses, then also it will not create any issue in case of quadruples. While if we consider the case of triples, in case of triples, if I will be changing the location of one of the memory address, then I need to change the respective location of this specific row in the wherever it has been referred. Like in 4th one has been referred, so I need to change its address here also. And in case of indirect triples also it is quite easy. If I will be changing here row, like I will be moving this data to the 15th address data to the 17th address, in that case I just need to make a change into the list of pointers only. That's it. And apart from that no other changes needs to be done. That's all for today. Thank you for attending this lecture.